So we are in time to catch the parachute drop. It's a few minutes away now, maybe 5 to 10 minutes. It's not an exact time. So we've got with us here at the Hangout Clara Moskowitz from Space.com and Eric Berger, the Sci Guy from the Houston Chronicle. They're going to be asking questions a little while later, but of course we also want all of your questions as well. You can send us in a number of ways. Of course, the best way might be the Google Plus Hangout itself, but you can also send questions in from Facebook at facebook.com/NASA or on Twitter, twitter.com/NASA, and use the hashtag AskOrion, AskOrion. Like I said, we've got a few minutes before the actual parachute test hangout, or the parachute test again. So here, tell us a little bit about it. We have CJ, John. Thanks so much for joining us, CJ. Why don't you tell us about what you do?
I'm the project manager for the test parachute.
We have really bad echo
with the projects that TSC is doing for the Orion.
Okay, so tell us what are we testing?
Today, coming out here again to the 10th test, we come out here to test our engineering development system. The engineering development unit is our precursor to what we will fly for human-raised spacecraft. And so we come out here and do tests to verify the performance of the system and to make sure to see if we identify any issues with the hardware itself so that we can make any improvements to it prior to solidifying the design for the Orion spacecraft.
We've done that a few times before, right?
That's right. This is our 10th test.
What's that testing?
Today's test, each test when we come out here is really to go after a unique set of objectives, which could be a combination of different failure scenarios that we want to go and understand, as well as environmental conditions. The parachutes have to operate in a wide variety of different velocities. We want to make sure we test through the entire region. For today's test, for the first time, we're actually extracting the entire system from the aircraft at 35,000 feet. We worked through a waiver process with the military to be able to accomplish this. In previous, that's the highest there. Previously, we've done our testing at 25,000 feet, and that's that when the drogue parachutes are deployed, which are the first set of parachutes that are deployed, when the Orion vehicle into the atmosphere, they're generally deployed around 25,000 feet. When we come out here and do a test, because we extract the whole vehicle out at 25,000 feet, given previous limitations, you're unable to really deploy those drones at the same test conditions. So we've always had to deploy a little bit lower and do some analysis to stand and make sure that we're still comfortable with where those parachutes are still operating. Fortunately, now, with the waiver process, we're able to accomplish a higher altitude vehicle extraction such that when we deploy the parachute, we're able to deploy them out. So for today, actually, you're going to see a total of roughly 17, 19 parachutes. The Orion system itself, the ones that we're testing today, there's 8 parachutes. The first set of parachutes are 2 drogue parachutes. They're deployed to stabilize the vehicle and to further decelerate the vehicle into conditions that we can deploy the main parachutes. Once those conditions are good, we then cut away the 2 drogue parachutes, and 3 main parachutes are motor deployed, or 3 pilot parachutes are motor deployed, like cannons, and they pull out a big 300-pound each main parachute. Yeah, if we were to take all 3 main parachutes, spread them out, lay them out, cover a little over 3/4 of the parachute.
Okay, so thanks a lot. I think we're coming back from, I think 3,600 feet for our first mission, exploration flight number 1 this year. And after that, it'll be around the lunar orbit area, and then from deep space down. So they've got to do a pretty heavy job.
They do. Yeah, they got to be tested. It is interesting. These are the largest human-rated spacecraft parachutes that has ever been built.
Okay. Well, so I guess part of that is let's make sure that they work no matter what we're operating, right?
That's right. When we do the test, after the test, we collect a lot of data both on board and from imagery. We have several other aircraft flying at different altitudes to capture imagery, and imagery is another important piece of data that we get. We're able to do imagery analysis post-test to evaluate performance as well. In addition, after every test, we inspect the hardware very thoroughly because we want to make sure that every element and every piece didn't experience something visually that we can identify as an issue, even though it may not have failed. And so every time we do a test, we learn something and we feed the change into the design. And we do that routinely so that at the end of the senior development series and all the testing that we do we're comfortable that we have a very robust system for human rights.
When we see it, only look, right.
That's right. When we come out here again, in addition to the different environmental conditions that the system is deployed in, we want to test out several different failure scenarios, even ones that may not necessarily happen, but still potential. In other words, we're not in requirements, but we still want to understand one more level deep beyond requirements to make sure that if something, it is still a robust system.
Really carefully. Engineer, we have to make sure it works. We want to make sure that even if it doesn't work.
Yeah, so today, one of the failures we're going to simulate is when the three main parachutes are deployed. One of the three main parachutes we're going to simulate a failure of that main parachute. So after the three main parachutes in flight, one of the three main parachutes will simulate a failure in the riser, so that it could be a scenario where it was cut too early by the riser cutter, or it can simulate a failure scenario where there was an overload condition and the riser failed. So either of those conditions could, we're trying to simulate what would happen.
So it won't actually watch the cut away during the day, correct?
That's correct. Yeah. So you'll be watching the actual failure scenario that we're simulating in demonstration.
So we'll see the three enormous parachutes in flight, and then one of them will fall away.
That's right.
If everything goes well.
Yep. One of them will fall away. And we're doing it in sequence too. Every time we come out, we're trying to get as much data as we can feedback into the there is an additional thing we're evaluating today rebalancing the load in the communication system.
A little wider than full, right? That's right. We don't go to full open on the main parachute. We open up a little bit at a time to limit the amount of energy and the amount of load that can occur through the inflation. Okay. So the second stage of the main parachute is actually two of them. We're changing the reaping schedule to see if we can rebalance and close a little bit through all the different scenarios that the mains have to operate through. Okay. So what we'll see today is we'll have some drogue parachutes come out first, then the three big red and white main parachutes. Good thing. Don't worry about it. That means the test is going well. But I guess we also know that the test we could have problems. So walk us through that. Yeah, there are scenarios. Every time we come out here, there is risk involved. We can kind of look through all the different scenarios that there could be to ensure that we reduce. There is risk in these tests, and it is on purpose. I mean, we want to find that out now, later.
That's a part of our
ensuring that we do certainly have a robust system supply. So failure is part of learning, and there is always a possibility when we do these tests that there is something that happens that we learn from. Okay. So what will you be watching for? Is there something you can watch for here on the ground to see if it goes through? Yeah. So our control model will be great. You'll have to let me know if this is able to be seen on the video. I think we're getting essentially, this is the vehicle stack that is coming out of the aircraft. It really consists of two different test pieces. One is what we call the parachute test vehicle. It simulates the Orion spacecraft capsule. The other piece is on coming out of the aircraft. So when it comes out, these two are going to separate, and there is risk involvement. A programmer parachute is deployed. A programmer parachute is deployed, which further decelerates this into the right conditions that start the sequence of the Orion parachute system. All this will probably be kind of like a dot. So you'll probably see more when you get closer to main deployment. So I think we're starting to.
Yeah, I think we're just about there. So we're going to look at trying to. It's going to be a little difficult to catch with our camera, but we'll get it for you as soon as we can and follow it along. And CJ, maybe you can kind of give us a quick
Programmers. What we have right now is on the radio, they're calling up the event. So we can listen along.
Great, thanks. So I know it's 35,000 feet, so it's going to be a little hard to see right away, but I think we can make it out down here, right?
Yep. You can see the programmers.
Very light white against blue, so but we'll be able to get it.
Now the program has released, and both two drones were deployed. So we'll further decelerate under the two drones until we reach about 8,000 feet, and those two drones will be cut away, and the three pilot parachutes will be border deployed to pull out the three main parachutes.
Hopefully y'all are able to start making it out a little bit. It's getting a little clearer. Still just white against the blue at this point, but it'll get more visible as it gets closer. Okay.
Two drones will cut away. First stage, three pilot parachutes pulled out the three main parachutes. There's our simulated failure, where we simulate one of the main parachutes failing. And it then descends on into two main parachutes. Second stage, land, deploy, full open. Trumpet range.
Great. So I know there's a lot of data to gather, but that's didn't get caught up in anything, so that's a good point there, right?
Yeah, just visually, it is hard to tell all the details, but visually it looks like we had a successful test.
Right. So it'll take a little while to come down now, but the main thing is we've got one of the three main parachutes cut away, just as planned, and
We're back there.
at this point in a real return, things will be slowing down a lot for the astronauts. They were coming back from space, right?
That's right.
And hopefully gliding down to the general return, not in the desert though, would actually be landing in the Pacific Ocean.
That's right.
Why is that?
Land landing has a lot of complications to it. When we do testing out here, we have, even though we're simulating the spacecraft, inside the spacecraft, it's all steel structure, and we do have some foam attenuation that we use in order to reuse the vehicle. But on a real spacecraft, a land landing, you would need some additional attenuation, which means additional mass in order to accomplish that. For the Orion spacecraft, we are kind of limiting what we can in terms of mass and trying to meet all our objectives. And so we are landing in the ocean to minimize the additional systems that we would use for a land landing.
So this is a good place for us to test for several reasons, right? In the desert test.
Yeah, this is a great place. Part of why we test out here is we have good cooperation with the Army and the Air Force. They have the resources to be able to accomplish a test like this. We're using the extraction technique that has been developed in the past for other military reasons, and they do those types of tests out here anyway. So we kind of adapted from that technique the ability to extract a simulated spacecraft off of a test platform to be able to do full-scale testing, which is really important for parachutes.
Great. About how what speed will they land at?
Roughly 24 miles an hour with the stage cut to land at.
Onto the water. And I guess on here too as well.
Yeah, with the simulation and under 2 parachutes.
Right. And we talked about, two parachutes is what we actually need, right, for the landing. The third is just a redundancy.
Yeah, the way we're kind of building the parachute system is that we have a parachute for each of the parachutes. And we just decide to deploy those backup parachutes at the same time.
I'm sorry. It's a little hard to hear you, so we'll have you speak up just a little bit, and I'll move the phone a little closer. So it's just about touchdown now, right?
Yep, looks like right there we have touchdown.
Excellent. So good test so far as we know?
Yes, everything looks really good.
Great, that's good news. What happens now?
We're going to wait for the remainder of the parachutes to descend and land. We also have a couple of what's called wind packs. The C-17 aircraft is doing another circle, and they're going to drop 2 wind packs which collect atmospheric data, and it gives us information that we use in post-processing to evaluate, and it gives us the most representative conditions of these parachutes at the time of flight.
Okay.
So we wait for all that stuff to land, and then once we receive approval from the safety officer here, we go out and start to recover all of the hardware that has landed on the parachute. They have several different teams that we put together to go after the different elements because they are going to be spread around the desert floor. We have teams going after each of the main parachutes, teams going after the drogue parachutes, teams going after the pilot parachutes, and teams going after all the other parachutes beyond just the Orion parachutes that are involved with the extraction. Just got a call from Color 1 2 they're clear. In addition, we try as best we can to even collect, like when the drogues when they fire, the lids for those drogues, we try to find those. Collect just all the hardware that we can find in order to make sure we can inspect it and learn from it.
And y'all have been working towards this test for quite a while, right?
Yeah, we do testing about every 3 to 4 months out here in YPG. So the 35,000 feet was an important one. So we've been working on it for some time. But we do have a lot of overlap with tests, given that we test every 3 months, roughly 3 to 4 months.
Okay. Well, thanks so much for joining us. It looks like it was a great test, and I'll let you back here a little bit more. But I think we have some videos that'll show you a few different views of it. I think first we've got kind of a interview we recorded earlier this week before the crew module was actually loaded onto the plane, and that'll give you a look at what that looks like up close. So we're going to switch to that now. Just hang with us, and we'll take questions in just a bit.
GTFS touchdown.
Very technical operation, but the behind the scenes on the Google Plus is a little low tech, and we're doing the best we can. We're about an hour and a half away from civilization, so it's a little bit of work to get this all up and running. But the guys who actually run the test themselves are clearly doing good. Ready?
Are they hearing the interview? No?
The object is one of our pilot parachutes, and each of the main parachutes is deployed by one of those pilot parachutes. Here. Unfortunately, we can't see from this vantage point the 2 drogues and the other 2.
So if y'all can hear me, can you confirm that you're seeing the interview? Maybe explain the quick crash course of parachutes. What are drogues and pilots?
Sure. So the drogue parachutes are order deployed parachutes. Motors are pyrotechnically.
No audio?
We'll post it on video. Let's just have a close up of what it looks like from the previous test in the audio.
Okay, got it.
we're showing the previous test now. Yeah, actually, you can narrate it.
Okay. So right now you actually should be seeing the last test. Since we thought from the ground, we thought we'd give you a different view of what it looks like from the air. So this is the previous test that took place a few months ago, and we had a different failure scenario that we were testing that time, so it looks a little bit different than this one did, but this gives you an idea of what it looks like, not from 35,000 feet away on the ground.
And that's we can show loading activities next. Loading activities from yesterday.
Okay, and we also have, these are some of the loading activities earlier in the week, getting the capsule actually on the plane. That in itself is a pretty big deal. The crew, like CJ said earlier, works pretty hard leading up to this test, and that's kind of the final event. They've made sure that all the systems are correct, batteries are charged, parachutes are packed well, and ready to go. All right.
You ready for that too? We're on you.
Okay. So that was a look at some of the up close and looks at the test today and the way up to it.
I'm here with Chuck John, who is with the Yuma Proving Ground Public Affairs Office. He can talk a little bit about Yuma, and like I said, we're complex civilization. This is a really big area. So what all do you do here?
Well, my job is with the public affairs office. We have 2,500 people who are scattered around a range that's about the size of it's actually larger than Rhode Island, but a third of the size of Massachusetts. So it's a huge range that we have here. And basically, the whole purpose of the UN-approved ground is to test weapons systems and munitions for Army, the Marine Corps, American military services, as well as a number of foreign countries that also come here to test. Pretty much anything that was seen on TV during the Afghan combat operation or in Iraq went through testing. It was used as a ground system during that conflict. We test tanks, we test artillery, we test parachutes, we test unmanned aircraft, we test technologies that defeat roadside bombs. You name it, we test a wide gamut of military hardware. And one of the things that people are proud of is that there were about, nobody really knows the exact number, but several thousand injuries and deaths to American servicemen were prevented during combat operations due to testing that took place in Yuma.
Wow, y'all stay pretty busy. I think I heard on any given day 100 tests, maybe?
Yeah, there's about 100 tests every day, partly because we're so large, we can separate tests. We have mountain ranges that separate test areas, and it's just a wide variety. Some testing grounds tend to specialize in one type of test. We're a multiple purpose testing operation. Today, just with NASA being here, we do about 36,000 parachute operations per year. That includes personnel parachutes. That's those that actually.
How many of them have spacecraft on them?
Yeah, good.
So we're unique in that way, and I think NASA has a long history of working with y'all, right?
Yeah. Believe it or not, NASA first came here in 1966.
Wow.
When they tested the lunar rover from the earlier model out here at Yuma. And so our relationship with NASA goes back a long ways, but NASA's been testing parachutes out here, I understand, since the 1980s.
So space shuttle program and on.
Yeah.
All right, well, thank you so much, Dr. Rizzi. I appreciate you letting us do our test here and also talking with us today.
We're always welcome, and I know the media here at Yuma loves that.
All right, thanks. All right, so I think now we might have some time for questions. CJ, if you want to come back over and answer a few. I guess we'll start real quick with some from our guests. How about we go first to Sarah Moskowitz from Space.com.
Hi, thanks for having me today. I'm wondering how similar the parachute system on Orion is to the parachutes used on other space capsules, such as the Soyuz or even the Apollo capsules.
Yes, and how is it comparable to some of the other parachute systems on other spacecraft?
Yeah, so, we'll start with Apollo. A lot of the heritage that parachute vendors and industry have really, there's a lot of data and that during the Apollo time period reflected on the design of parachutes. So a lot of that is really the base for parachutes that we have today, in addition to other systems that have been deployed out there in industry since Apollo. So we take a lot of what have the capabilities and the designs that are heritage and use that as the base for the system that we fly.
And before Claire asks her next question, just a reminder that you can ask questions from home several different ways. You can do it here on the Google Plus Hangout or also at the NASA Facebook account, that's facebook.com/NASA. And of course also on Twitter, use the hashtag #AskOrion. Sarah, any other questions from you?
Yeah, and I'm sorry if I missed this if you said it before, but I'm wondering if the Orion is designed to land on water only, or will it ever make land landings?
The Orion spacecraft is a water-only landing vehicle. It is designed specifically for landing in the water.
Okay, thanks very much.
Okay, and we also have Eric Berger, the sci guy from the Houston Chronicle. Eric, do you have any questions for us?
Sure, good morning. The question I would have is, I understand the space shuttle came back at about 18,000 miles per hour. I'm curious what the maximum speed that the space shuttle came back at about 18,000 miles per hour. How fast is Orion designed to come back at? What's the maximum reentry speed it could be able to handle?
The maximum reentry speed for Orion.
I think it's on the order of 24,000 miles an hour. I'm going from memory. It's a relatively very high speed, a reentry speed that is beyond what the space shuttle has been capable or was capable of. The Orion vehicle and the DCS specifically is being designed for the deep space reentry speed coming from another body such as the Moon or Mars or an asteroid.
And that's slightly faster than, say, the space shuttle did. I think there's about 17,000 miles per hour.
Yeah, it is much faster.
And it all depends on where you're coming from, I think.
That's right.
So for our first test, first mission here next year, the exploration flight test number 1, I think it's going to be kind of at a speed of about 20,000 miles per hour. And then the further we go out, the higher the speeds are. And then also the higher the temperatures for reentry. So that's why we need a good heat shield as well.
Okay, one other question I would have is.
I think we're going to try and get some shots of the helicopter coming in, but just so you know, even though you might not see it, we'll still be listening for your questions.
Okay. How many people would you envision the Orion taking in these deep space missions?
How many people would Orion take on the deep space mission?
I think it really depends on the objectives. Right now, the program is evaluating how to accomplish a deep space asteroid mission, how to accomplish different types of missions. So it really can vary. Certainly, a crew of 4 is what the Orion vehicle is capable of.
A crew of 4?
Yes.
Okay, Eric, any other questions?
No, thank you very much.
Well, we have, as I mentioned, we have several different aircraft or vehicles that are capturing imagery for us during the test. That helicopter right now is what we use at roughly 10,000, between 8 to 10,000 feet to capture parachute deployment. So it has video on board and it was capturing imagery for us to do analysis.
Okay, so that's part of what you get later to make sure everything on the test is well.
That's right. And then while it's here, we also use it to help in the search of items that are spread across the desert floor. So it'll hasten our rescue teams going out or recovery teams going out to recover the items.
All right. So we're going to take a couple questions from online now. The first one is, would the success or failure of the test today drastically affect the first manned launch of the capsule?
Well, that's part of the reason why we're out here is to learn. And for the first manned launch, which I think is 2019 for the Orion program, we would be taking the lessons learned and even a failure if we would experience a failure today and feed that into the design that we would then qualify to. So yes, we have time, and that's why we do these tests to provide that time to be able to react to failures, different things that we determine in order to modify the design for the spacecraft.
So, and that's an interesting point I know we talked about before. This test, we have the first mission coming up next year. We've already done all the tests we need for that. So these tests we're doing now are actually for something that's requested the first cruise mission in 2021 at this point.
Yeah, I think the key word was manned. We have the ESP-1 flight coming up at the end of next year, and we have done enough testing to have enough confidence in the system that we're flying, which is really what you saw, the same system that you saw today, flying on ESP-1, which is unmanned flight.
Okay, another question. What is the weight of the test article in comparison to the real Orion?
Well, part of the beauty of doing the testing out here with the test assets. Oh, yeah, the close to the helicopters love to land and do a lot of stuff up here. So, the weight of the spacecraft is, what we're simulating out here, 22,000 pounds. So our full scale, full mass representation.
I mean, that has to be a little shorter than the real module, right?
Yeah, the one significant difference in the test vehicle that we have as opposed to the spacecraft is in order to fit it in the aircraft, we have to shorten the simulated spacecraft test a little bit. So that is one difference, but we can account for that in all of our analysis. Yeah, that's what part of the Orion program is looking at assessing too. The base spacecraft design that we have today is the vehicle that is going to be capable of taking us to Moon, to asteroids, to Mars. Really depends on the objective. Once we learn the particular objective for a mission, there will be augmentations to the spacecraft that will be made in order to, so there might be retrofits for certain mission kits that are needed. But the Orion design really is what is to be capable of being used for Mars, Moon, or an asteroid.
So did you guys, I mean, that's kind of exciting to be a part of it. Does it help you get excited for the coming, like, mission?
Yeah, I think, it's a large part of the motivation even from the team that worked on the spacecraft, that worked on the parachute. A lot of people are just motivated by the fact that we're working on the next manned spacecraft for NASA. And so that excitement, you see it kind of generate self-esteem. And it's their motivation why they come to work every day to work on these things.
I don't know if we have any students listening, but you can also be a part of the mission. We've got an important design challenge going on right now where students can learn more about radiation and how it affects astronauts in space. And then older students in high school can also design a radiation shield. And so we'll pick one of the designs. The best design to actually fly on our first mission and flight the next one next year in September. So if you are in school and listening in, hopefully you are taking part in that, or if you aren't already, you can get signed up soon. You can go online at www.nasa.gov to learn more about that. And again, search for the Exploration Design Challenge. And you find out more on nasa.gov /Orion for more information on Orion as well. So what happens now, CJ? We got this helicopter back, and where do they go from here?
Yeah, they're changing out some of the crew. Some of the people are coming off. They're going to be going in the other helicopter. And again, they're going to go out and just for some of the recovery and the items for identifying where they are. We have already, like, we're sending out our first set of teams to the test vehicle to save it. We have to save the pyro systems that are on there before anybody else can approach the vehicle. They usually take 25 minutes or so. And then they'll get the team will get the green light to come up to the vehicle and start shutting down the avionics systems that we have, start the logic of the test, and start recovering the parachutes, especially the main parachutes, which are our big ones. We want to get them out of the sunlight because UV exposure can affect the main parachute material. So we want to get them in bags, out there pulling the main parachute together and putting it in the bag.
So you mentioned in there pyros. What are pyros? It sounds ominous.
Yeah, pyrotechnics. So there's different pieces of hardware that need pyrotechnics in order to perform. So one example again is we have for the stroke parachute mortars. What mortars are a pyrotechnic device. They shoot the parachute, which is packed in the bag. They shoot it like a cannon. So pretend like the packed parachute is a cannonball and the mortar is a cannon. They shoot the parachute out into the free stream. But one end of the parachute is next to the vehicle, and that is essentially deployed and the parachute into an inflation mode, and then the rest of the inflation happens with the parachute. And that's one example of a mortar. So we have to go and make sure that those systems did operate correctly, and there's no leftover energy that could be a hazard to the people working on the recovery of the vehicle.
Okay. Keep sending your questions in. We'll take a few more before we wrap up for the day. You can again send them in here at the Google Hangout or on the NASA Facebook account, nasa.gov/facebook.com/NASA, or Twitter at just use the hashtag #AskOrion. I think we've got a few more questions here for you. How different is the parachute compared to Mars Curiosity parachute?
Yeah, that's a good question. There are different types of parachutes. Parachutes for, say, a small vehicle re-entering the Mars atmosphere, they are designed for a different set of environmental conditions. Primarily, they are deployed in the supersonic. In other words, the spacecraft is traveling faster than the speed of sound when the parachute is deployed. That's a different type of condition environment. The parachute is designed differently to meet those conditions than these parachutes, which are deployed at velocity more on the order of hundreds of miles an hour.
Do you think are there lessons you learned from them, or
Certainly.
talk to them?
Yeah, certainly. One of the things we do at NASA when we try is using lessons learned and trying to learn across the agency. So we have talked with, in fact, team members include those that have worked on planetary parachute systems, and we always learn from each other on the building of the parachute and design and even the analysis of the parachute.
Yeah, did you watch along with everybody else as Mars was landing, or Curiosity was landing on Mars?
Yeah, you bet. It was one of my favorite pictures is once it landed and they took a picture of the sunrise. That was a very neat picture.
All right. I think our next question from online was, will the first Orion be suborbital? I guess that's probably the expiration flight test next year, and I think the answer is no, it will be.
Yeah, sorry. The Orion program, the ESP-1 vehicle, they're going to send that vehicle outside of Earth orbit. And the reason they're doing that is to be able to achieve an entry speed once it comes back to Earth and re-enters that simulates emissions from either the moon or an asteroid, and it evaluates the performance of our thermal protection system or the heat shield, which is a really important piece of information to learn from ESP-1.
Right, so there are good reasons for that. Maybe we can check back.
ESP-1.
Right, so there are good reasons for that. Maybe we can check back now with our guest, Clara from Space.com. How are you doing over there? Any more questions for us?
Oh, I'm sorry. I couldn't understand what Brandy said.
I was just checking to see if you had any more questions for us, Clara.
Oh, I do actually. Thank you. Yeah. I'm wondering, is the parachute system that you tested today the same system in all its specifications that will be sent on the first test flight in 2014?
Yeah. It's above the pizzeria. Or whatever.
Did you know your pizza?
One, that's the next question. Okay. Yeah. What the parachute system you saw today is essentially identical to what we're flying for the ESP-1 flight for next year.
Yeah, can you tell us more broadly how are plans coming along for the first crewed test flight, and is that still planned for 2021?
Yeah, the Orion program continues to evaluate the schedule and look at the future missions that we have. You know, obviously a lot of focus is on EST1 for next year. We have the EM1 mission that will still be uncrewed, and then the EM2 mission in the 2019 to 2021 time frame. That is still the schedule that the program is looking to.
So, and just for people who may not know, again, the EST1 is Exploration Flight Test 1 next year. That's the first mission for Orion. It's going to go up about 3,600 feet into orbit, which is higher than the International Space Station, higher than any spacecraft built for humans. It's been in more than 40 years. And come back to Earth, and we'll give it a chance to test out the parachute system coming from space and the heat shield and a number of other things. Then after that, in 2017, we're scheduled to have the Exploration Mission 1. That's going to be the first time we are launched on top of the Space Launch System that NASA is building, our new rocket to allow us to get into deep space. And then after that, our first mission with astronauts on it is Exploration Mission 2, currently scheduled for 2021. So, like we said earlier, this test is actually getting us ready for Exploration Mission 1. So, excuse me, Exploration Mission 2. So there are definitely activities already going on for.
That's right. Yeah, just as preparing us, the continuation of the test and evaluation are prepared for EM1 and EM2.
Okay, thanks, CJ. And how about we go now to Eric? See if he has any other questions for us.
Hi, sorry about that. I was just wondering, when we might know when today's test is likely to be successful or not.
When do you call it? Like we saw earlier, it looked like it didn't get caught. The parachute we cut away didn't get caught up in any other parachutes.
That's right. Just looking at the visually today, it looks like the events that we had planned for happened pretty much were to happen. And yeah, it looks like a success.
All right. Any other questions, Eric?
No, thank you very much, Brandy.
All right. One more reminder to visit www.nasa.gov for all your NASA news and nasa.gov/Orion to learn more about the Orion. Thanks so much for hanging out with us today, and sorry again for a slight delay in getting